I can exit that. Okay, we are there. Caleb, can you give me a thumbs up if you can hear me? Can you hear me? Are you there, Caleb? Oh, gotcha. Okay, thanks, sir. Okay, let's get rocking and rolling. Today we're going to cover 7.4, which is adding, subtracting radicals. Now, I'll tell you the tough part on adding and subtracting radicals isn't adding, adding, subtracting, and multiplying radicals. The tough part isn't actually adding, subtracting, or multiplying. The tough part's going to be simplifying from 7.3. Okay. You guys have any questions from the homework? No? Okay. Caleb, you got any questions from the homework, bud? I assume that's a no.
No.
Okay, thanks, sir. Was it 7.2? 7.2. Yep, 25. Oh, yeah, okay. So this is 7, get this kind of set. Page 524, number, you said 25? Okay, yeah, this one's not a big deal. So it just looks goofier. If you've got 7x plus 2 raised to the 2/3. Now the question asks to use radical notation to rewrite the expression. So there's two answers here, right? Remember, the denominator is the root. So it's the cube root of 7x plus 2 squared. Or you could write it as the cube root of 7x plus 2 and then square that whole thing. Yeah, either one of those is fine. It just looked goofier because it was a binomial instead of just a single term. Yeah, not a big deal. Not a big deal. Is there another one? Okay, so let's look at 7.4 now. So 7.4, we're adding and subtracting and multiplying. So we're going to start with adding and subtracting, but really multiplying is easier. Now, we have to remember we have to know, I guess, when you add or subtract a radical, you have to have a like radical. It's kind of like terms, so like radicals. So a like radical has the same root and same radicand. Okay, that's same root and same radicand. So I'm going to just kind of jot down some examples of like radicals, like the square root of 5 and -8 square root of 5. These are examples of like radicals, right? We've got the same root 2. We've got the same radicand 5, okay? If we had like the 4th root of x squared, y, and 2 4th root x squared y, right? Look, same root. They've got the 4th root on here. Same exact radicand. We have to have the same x squared y, x squared y. It's got to be the same thing under the radical, the radicand, right? And the same exact root. And if we have the same root and the same radicand, we can actually add these together. And you add the coefficients. So it's just like if you had like terms, like if you had like 4x squared plus 8x squared, it just gives you 12x squared, right? Well, it's the same idea. You're going to keep whatever the like term is, and it's going to stay the same. So our radical is going to stay the same. It's just you add or subtract the coefficients. So for example, this would be like 4 square root of x plus 8 square root of x. Look, we can add these together because they've got the same root, same root, same radicand, and you just add the coefficients. So you get 4 plus 8, so you wind up with 12 square root of x. Okay? So what's different is you're just going to keep whatever the radical term is because you're adding, really, and in all honesty, it's the same idea as like terms, because remember, this square root is just x to the 1/2, right? It's the same idea. It's just written different. It looks goofier. So now this works for addition or subtraction. So let's look at like subtraction. Like an easy kind of example. If we had, let's say 9 square root of 11 minus 2 square root of 11. Nine square root of 11 minus 2 square root of 11. Now again, look, we've got the same root. I'm sorry, same radicand, 11, and same root, 2. So because we have the same root in radicand, we can subtract the 9 minus the 2, and it gives us what? 7 square root of 11. Okay? Not bad, right? Pretty simple. It's going to grow kind of complex once we start doing kind of bigger things with it. Let's say we had 8 square root of 3 plus 2 square root of 2 minus 9 square root of 3. Okay? 8 square root of 3 plus 2 square root of 2 minus 9 square root of 3. Now with this one, not all three of these are like terms. This middle term has a different radicand. We can't combine this 2 square root of 2 with either of these because of that radicand. Now they've all got the same root, right? The square root, so that's fine. But this one's going to have to stay put. So I'm going to just write it first, 2 square root of 2. The outside 2, though, we can combine. 8 square root of 3 minus 9 square root of 3. Well, that's just minus 1 square root of 3, right? Now you don't have to write the minus 1. You can just write a negative if you want. That's fine, but realize that's all it is. Okay. Let me steal one from the book now. Okay. So I'm going to tell you, this is the easy part of these questions. The more difficult part is what we've already gone over, and it's just going to take a little time sometime to show, to show that they're like radicals. Like this is an example straight from your book. You guys see that up there? Yeah. The square root of 20 plus 2 square root of 45. And I know what you're thinking. You're thinking, wait, Mr. Shirley, those can't add together because they've got different radicands, right? And they can't the way they're written, but you have to simplify them completely and then see if they add, okay? So I'm going to simplify both of these completely like we did 2 days ago in 7.3. So the 20, remember I like doing the factor tree. So 10 times 2, 5 times 2. So I can take out a 2. And I'm left with a 5, right? That would be the 20. So you can take out the 2 because it pairs up. Remember, it's square root. So take out the 2. Leave the 5. Can't come outside. 45, though, is that 9 times 5? And then 3 times 3. Hey, I can take a 3 out. Now, there's already a 2 there. And remember, this is all multiplication. If you did that simplifying section, you came to one that looked just like this. But this is all multiplication. So when you take the 3 out, you multiply it with that 2. So you wind up with 6. Square root, hey, there's a leftover 5. Hey, look at that. It turns out that these are like radicals. It's just that they had to be simplified first before you could combine them. And let's say we simplified these and they turned out to be not like radicals still, you still have to simplify them completely. Okay, and that would be your answer. If this was like 2 square root of 5 plus 6 square root of 7, then you just box it in and you'd be done. Okay, but we have one extra step here. This is going to be what? 8 square root of 5. Okay, pretty straightforward. Any questions? Not a big deal. And notice what took long for this question was the simplifying, not the adding the like terms. And that's typically what happens. What takes longer on these questions isn't the simplifying. It's going to be adding or subtracting like terms. Okay, let's look at another. I'm going to steal another one from your book. I want you to try this one. This is cube root stuff. Cube root of 54 minus 5 cube root of 16 plus the cube root of 2. So try this one. I'll give you a minute. Simplify. The way they're written, they can't be added together, right? But simplify them and see if they can be added together. Okay, let's run through this one. The portal, I just got an email saying the portal's down. So that might be why no one's in class. How did you just go to Zoom and then go to it? Yeah. Okay, yeah, that's why. Yeah, I bet a lot of people. Oh yeah, like directly to Blackboard. Yeah, I go directly to Black. I don't even mess with the portal anymore unless, I mean, we've got employee stuff in it, but yeah, there's no point because it's always down. Okay, so 54. 54 is what, 9 times 6? Which both can be broken down. 3 times 2, and then 3 times 3. So yeah, I could take out a 3, right? Remember now we're doing the cube root. So this winds up being take the 3 out. And we have 3 cube root of 2. So right away, I know that's going to combine with the cube root of 2 over here. And let's see, 16. Yeah, 16 is a bunch of 2s, right? So I can take out 3 of the 2s. Now that's 2's got to stay put. Now there's a 5 there. So remember, we're going to multiply it. Cube root of 2. Yeah, all these will add together. So since they're all like terms, we're going to say 3 minus 10 plus 1. So that's what, negative 6. Cube root of 2. Yeah, this marker's a little fatter, so it's kind of weird shifting to it. But that's negative 6 cube root of 2. Probably go through. Okay.
Question? Mr. Shirley?
What's up?
I have a question. Okay, I got the last part, but how did we get the answer? I totally spaced that out. I missed something.
Did you get this part? Did you get did you get this part?
Yeah, I got all that part, but when we got to the answer, I messed it up somehow.
No, that's fine. You just add the coefficients. So 3 minus 10 plus 1.
Oh, okay. That's what I missed.
And that, yeah,
yeah. The 1. Yeah, I didn't have the 1. That's what I've missed.
Oh, yeah. That's a 1. Don't forget.
Yeah, I didn't have it written down.
I got you. All
right, thank you.
No problem. Okay, so we do have someone on it. It's weird to see, like, look, you can't see it whenever it's. Okay, let's try another one. This one is going to have variables, so we'll see what happens with it. Let's say we've got the square root now of 27x. The variable's not even going to come out. Minus 2 square root of 9x plus the square root of 72x. Okay, so try those. So you're definitely going to have to simplify them again because they don't. They're not like at the moment. So try that. See if I can get an update on. I'm going to start on this one because I know all 3 are going to have to be simplified, and I don't have that much room left. Okay, so let's see. 9 times 3. 3 times 6. Now it's a square root. So in that first one, I can't do anything with the x, right? 2 doesn't go into 1, so I can take a 3 out. I'll write it over here. I'm left with the 3 though, so it'd be 3 square root of 3x. Okay. So the first one just turns into 3 square root of 3x. Can't do anything with the x. If it was like x squared, I could, right? That'd be just x. I'd take it out. Or like an x to the 5th, I could take some x's out. But can't do anything. So let's do 9. Well, 9 has a square root. It's 3. So the square root of 9 is 3. I've got to multiply it by the 2. Right? Square root of 9 is 3. 3 times 2, 6. Now it's negative. But then that x again. So look, these aren't like terms. We won't be able to add those together. Let's see if this last one maybe turns into something we can add to one of these two. Gosh, 72 is 9 times 8. 9 is 3 times 3. 8 is 2 times 2 times 2. I'm going to go kind of skip the 4 times 2 part. Now I can take out a 3. I can take out a 2. I'm left with a 2, though, with 72. So when I do that, that's a plus. I've got to multiply these when I take them out. So I'm going to take the 3 out and the 2 out. So that becomes 6. I'm left with a 2. And don't forget the x here. Oh, man, none of these are the same. You guys see that? So look, we can't add any of these together. They're not like terms, but we had to simplify them completely, okay? We had to simplify them completely, even though we couldn't add them together. Kind of goofy looking. That's just how it is. Okay. Questions about that? Not bad. Ask. We got plenty of time today. There's going to be plenty of time. Okay. Let's do another one. Let's see here. Ugh. Okay. Yeah, let's do one with a variable. I'm stealing this one straight from the book. Let's say we've got the cube root of 48 y to the 4th plus the cube root of 6 y to the 4th. So simplify both of these, and I'm going to tell you, you're going to get like terms if you do this correctly, okay? So simplify both of these and then combine them together as one. I'm going to add one behind underneath it too. A little challenging one. Let's see here. You're not going to like this one. The square root of 45 over 4 minus the square root of 5 over 3. So yeah, try those two. I'm going to start this first. Keep working. You guys work. Let's see if I'm on the right path. 48. 48. Geez, that's 6 times something, right? 6 times 9? No. 54. 6 times 8. Man, basic math is just from one semester kind of being off. It's crazy. 2 times 2 times 2. Okay. So 6 times 8. 6 is 3 times 2. 8's breaking down to the 3 2's, right? Now we're looking for a cube root. So I need to take this 2 out. Okay, so I can take the 2 out. Now the y, though, it simplifies as well because it's y to the 4th. Remember, 3 goes into 4 one time. And then left over, now look, the 3 times 2 is left over, so a 6 is left over. And 3 goes into 4 one time, and then it has a remainder of 1, so 1y. So the first term simplified would be 2y. Now that's not y cubed, that's a cube root there. So 2y cube root of 6y. Plus, now I don't have to worry about the 6 because 6 is just 3 times 2, right? So I'm not going to have 3 of a kind. And I know how to simplify the y, and just need to take the y out. And there's a y left over, right? 3 goes into 4 once. I mean, if you want to write the 1 exponent, there's nothing wrong in that. Just realize it won't be on the test, right? Your final answers on test won't be that way. And notice that these are like terms. And it's kind of like double like terms here. We've got the like term radicals, but also we have like terms as coefficients. So we can add them together, right? 2y plus 1y would be 3y. Cube root. Now remember, we keep the 6y. There's a lot going on there, okay? A lot going on there. So 2y, and then we get the cube root of 6y plus y cube root of 6y, and you add those together. So the 2y plus the y gives you the 3y, okay? So now let's look at the fraction. So before we get started on the fraction, let's simplify. Like if you look at all kind of 4 parts, the only thing that simplifies is that square root of 45. Square root of 5 is the prime number, right? So 45, I'll do it up here because I've got blank space. Is that 9 times 5? 3 times 3. So I can write that first fraction. I can take the 3 out. The 5 is left over 4. Now I'm going to kind of gap this a little because I'm going to have to create a common denominator. So minus the square root of 5 over 3, right? Now we've got to get a common denominator. The easiest way to do this, of course, is to just whatever the denominator is on the other fraction, multiply it to the top and bottom of the other fraction. So if I've got a 4 here, just multiply by 4 on top and bottom. I've got a 3 here. I'm going to multiply by, not 4, but 3 on top and bottom. Okay, that's a 3. So you wind up with 9 square root of 5 over 12 minus 4 square root of 5 over 12, right? And now look, we've got common denominators. We also have like radicals, right? Square root of 5, square root of 5. So that means really we can subtract the 9 and the 4 together, okay? 9 minus 4 is 5. So this one ends up being 5 square root of 5 over 12. Boom. Okay. Zoom in a little. Makes it a little bigger. Questions? Makes sense. Adding and subtracting or adding and subtracting radicals. That's pretty much it. Now we're going to go on to multiplying, but part of multiplying will be adding and subtracting. That's why it goes over it first. Okay. Because when you multiply, a lot of times after you multiply, you have to see if you can add or subtract. So it winds up being part of the next concept. So let's look, what about multiplying? So multiplying, we've gone over a little bit actually already, but to multiply, all you have to have are the like roots. So to multiply, almost perfect. To multiply, if we had like the nth root of A times the nth root of B, as long as those roots are the same, you can multiply it underneath, okay? As long as those roots are the same, you can multiply it underneath. So if we do kind of some basic examples with this, if we had like the square root of 5 times the square root of 2, okay? Square root of 5 times the square root of 2, just going to be the square root of 10, okay? Or if we had, let's say, like 3 square root of 7 times 4 square root of x. They're square roots, so that's fine. We can multiply these together. Now look, we've got coefficients that are going to be multiplied together, and we have radicands that are going to be multiplied together. So the coefficients, 3 times 4, that gives me 12, right? We're going to keep the root, and then 7 times x, that's just 7x, okay? So you multiply under the radicals and in front of the radicals, and you keep them separate. It's like coefficients and variables in a way. You keep them separate when you multiply them together, okay? Let's say we just wanted to multiply a number through. Let's say we had -4 times 7 square root of 3. -4 times 7 square root of 3. Now, if we had something like this, you don't distribute it to both parts. That's not how this works. To multiply under the radical, you've got to start with the radical. So since this is just an integer without a radical, you would multiply it to the coefficient, okay? So this winds up being -28 square root of 3. -28 square root of 3. And all kind of 3 of these are going to pop up. You'll see what I'm talking about here in a second once we do these. So multiplying, let's look at, I'm going to steal one straight from the book. Let's say we had the square root of 2 times the square root of 6 minus 3 square root of 2. Now look, we know with parentheses, you're supposed to do what's inside first, right? So if you look at these though, you'll notice you can't add them together. The square root of 6 and the square root of 2, and 6 doesn't simplify, it's just 3 times 2. So these two are not like terms. We can't subtract them together, right? We had to have the same radicand to do that. So we can't subtract them together. So then we're going to distribute now the square root of 2 to both terms, okay? Now I'm going to write this out long-wise for this first example, but I'm not going to do that ever again, okay? It's just too many steps. So this winds up being the square root of 2 times the square root of 6, right? Minus 3 times the square root of 2 times the square root of 2, okay? We've distributed it. We've distributed the radical through. This winds up being the square root of 12, right? Square root of 6 times the square root of 2. That's just like this square root of 5 times the square root of 2 up here. That's just the square root of 12. Minus, now the 3 can't go anywhere, but the square root of 2 and the square root of 2 just become the square root of 4. I'm going to pause right there. We've got to simplify this, but I'm going to pause right there. Make sense? Okay. Letitia, are you still on there? Does it make sense? Are you there? Can you hear me? Are you following along? You can give me a thumbs up or anything. It's okay if you're just sitting back there chilling too. I'd be eating cereal in my pajamas if I was in this class. Okay, anyway, so let's simplify now the two radicals, okay? We can't complete this if we don't simplify the radicals. The 12 would be 6 times 2, 3 times 2. Okay, we can pop the 2 out. 3's got to stay. 2 square root of 3, right? The 4, though, the square root of 4 is just 2. So then you multiply it with the 3. So it becomes -6. Okay? So 2 square root of 3 minus 6. Not a big deal. Okay? Questions? Not too big of a deal. Let's do one more that looks like that, and then we'll get into like the bigger stuff. Let's say we've got, I want you to try this one actually. So we've got the square root of 7 times 2 plus the square root of 14. So try that one. We'll see if we're on track. Okay. These don't add together, right? We've got an integer and a radical. They're not going to add together. So I've got to distribute the square root of 7 through. Now look, remember, if this is just a number and a radical, you can't multiply them, but you write them like coefficients. So this becomes 2 square root of 7, okay? Just 2 square root, and that really just represents 2 times square root of 7. Now the square root of 7 is square root of 14. That's going to be, what'd you guys get? What's 7 times 14? 98? Okay. Okay, we're going to have to see if that simplifies. I know the 7 won't because the 7 is just a prime number, but 98 probably simplified. And we know it's 14 times 7, right? And then it's 2 times 7. Yeah, we took 7 out. So this winds up being 2 square root of 7 plus 7 square root of 2. Kind of looks like you can add them together, but you can't because the radicands don't match up, 7 and a 2. So we are done right there. We completed this task. Okay? Questions? So, okay, I want you to do this one. So now you're going to have to FOIL through this one. So the square root of 5 minus the square root of 6 times the square root of 7 plus 1. Okay, you try this one. Remember, you got to do first, outside, inside, last, right? So first, outside, inside, last. That's a minus sign right there. Okay, keep going, guys. I'm going to just start doing the same thing you should have been doing. Just FOILing it out. First, we're going to get the square root of 35, right? First, outside. So 1 times anything is itself, right? Square root of 5. Inside, we get minus the square root of 42. And then lastly, we get minus the square root of 6. I don't think any of those simplify, right? I mean, 35 is 7 times 5. It doesn't simplify. Those are 2 prime numbers. 42 is 7 times 6. 6 breaks down to 3 and 2, but 3, 2, and 7 don't simplify. 5 and 6, of course, aren't going to. That's it. I know it doesn't look like it should be, but that's the answer because none of those add together or subtract together. They're all unlike radicals or whatever we called it. Non-like radicands. Okay. I'm going to dig into some homework questions now. Oh, let us see here. Okay, this is, I want you to try this one. This is 56. 56 in the homework. The cube root of a plus 2 that's in the first parentheses, and the cube root of a plus 7. Try that. Cube root. It's hard to say. I'm going to start this one. So cube root of a times the cube root of a. Okay, well, we have to multiply the a's together, right? So we wind up with the cube root of a squared. And then the outside, well, again, you've got just an integer and a radical. You're going to just notate it by putting the coefficient out front with the integer. Or it doesn't have to be an integer, it could be anything. 2 times the cube root of a, same thing, right? Then lastly, 2 times 7. Hey, I know that one. That one's not crazy. It's just 14, right? Now, hey, what does happen on this one is those two can add together, right? Those two are like terms. We got the a, we got the cube root. So this winds up being, now look, we can't simplify this. 3 doesn't go into 2, right? The opposite would be true, but not this way. So cube root of a squared plus 9 cube root of a plus 14. Hey, did I get it right? I did. I've got the answers. Okay. Makes sense? Okay, let's do some that just look goofy that really aren't that bad. Okay. This is number 40. Actually, I'm going to make it up. If I can still be stable. I'm going to say it's like 50, but I'm going to write it a little different because you're going to see it on 49. We've got 3x minus the square root of 2 squared. Okay. 3x minus the square root of 2 squared. So look, okay, I'm going to tell you guys. This is probably my number one pet peeve in all of algebra. And not pet peeve. I just see us do it over and over and over again, especially in this class. We see this too. And because we went through the exponential section, we want to distribute it to both terms, right? I mean, you guys remember that section, hopefully. It wasn't too long ago. But you can't do that if there's a minus or a plus sign here. If it's like a binomial, trinomial, things like that. Now look, so I'm going to do an example where we could do this. If this was like 3 squared to 2 squared, we could do the exponential terms. We could distribute it in. This would be 3 squared times the square root of 2 squared. And it'd wind up being like 9 times 2, so 18. Okay. But up here, we've got a minus sign. So we can't distribute exponents through with more than one term. That's that kind of the rule. So what we have to do is we actually have to lay it out with the multiplication. So this has to become 3x minus the square root of 2 times 3x minus the square root of 2. And then you just FOIL it out. Okay, so do that. FOIL it out from here and see what you get. 3x times 3x. Hey, no radicals there. We just multiply them together. 9x squared. Outside, we get minus 3x squared root of 2, right? Because we've got no radical and a radical, so you just kind of mush them together there. Inside, same exact thing, right? Minus 3x squared root of 2. And then lastly, we've got plus the square root of 4, right? Square root of 2 times the square root of 2. You got to make sure to multiply them underneath there. That's a common mistake, and just write the square root of 2. Okay, this will add, right? The middle two add. Those are the same exact term, so they've got to be like terms. So we wind up with 9x squared minus 6x square root of 2, right? Plus, as I know the square root of 4, it's just 2. Okay. Cool. Not bad, right? Cool. I mean, not that they get trickier or not trickier. You just got to work them to make sure you really get them, because there might be some curveball that I'm not even thinking of that might throw you off. You know, these are the ones that I kind of see that students have issues with from the past. Let's do one more. I forgot to do one that is just adds a little goofy element to adding and subtracting. This is number 42. So now we're back to adding and subtracting. 42 says the cube root of 3 over 10 plus the cube root. Now they do the whole fraction here, 24 over 125. Okay. So that's a 24 and a 125. Now they're both cube roots, so they've got potential to add together. They definitely can't add together the way they're written, right? So now we've got to use the rule with radicals that says, hey, look, if we take the cube root of the entire fraction, we've got to do it to the top and bottom here. So I'm going to rewrite this. This doesn't simplify at all, right? 3 is not going to come out. So we get the cube root of 3 over 10 plus, now let's break this apart. Okay, we've got the cube root of 24 over the cube root of 125. Now look, the cube root of 125 is 5. Like if you break this down, you know, it's 5 quarters, right? And then 25 breaks into 5 times 5. So this actually, since it's a cube root, it simplifies completely to 5 because there's 3 of them, okay? The 24 though, let's do that here, and I'll just work down. 24 is what? 8 times 3, 4 times 2, 2 times 2. So I can take out a 2 here, but that 3's got to stay under the radical. So if I simplify that second fraction, so the cube root of 24, I can take the 2 out because there's 3 of them. And then I've got a 3 left over. Now we said the cube root of 125 is just 5, okay? So that one took a little bit to go from here to here, right? But now we've got something that once we get like denominators or common denominators, we can add this together because we've got a cube root of 3 and cube root of 3. So the 5, I just need to multiply it by 2, right? But multiply this by 2, it's going to match the 10. But it's a fraction. You have to do it on top and bottom. So you wind up with the cube root of 3 over 10 plus, now this winds up being 4 because there's already a 2 there, right? So 2 times 2 is 4, cube root of 3 over 10. Now remember, there's a 1 here, right? Even though we don't write it, there's a 1. So we're going to add across. I know the denominator is going to be 10 because they're common. So 1 and 4, that's 5. Cube root of 3. Holy cow, this one's never going to end. Now look, 5 and 10 simplify, right? They're both divisible by 5. So this winds up being the cube root of 5, oh my gosh, cube root of 3 over 2. I'm going to rewrite that. So cube root of 3 over 2. Man, that one took a while. I didn't think it was going to take that long, but it was a longer question. Just because of that one. That one was messing us up, took us a while. And then we had to get so we had to simplify this one fraction. Then we had to get common denominators. Then once we added the common denominators together, we had to keep simplifying. Okay. Okay, cool. So now for homework, this section will be done a little bit early. Homework, I want you to do 1 through 43. These are all going to be odd. And then 47 through, oh yeah, don't worry about those. 47 through 69. So these are all odd. Don't worry about doing the evens. If you want extra practice, you can do evens on these, but I have a really good feeling if you can do that many, you'll be set. You'll be fine. Okay. So 1 through 43, it's on page 540. 540, section 7.4. Okay. Section 7.4. Okay, let me turn this. Let's see.